Hello, everyone. Hello. How's it going? I hear a little birdie told me that it's election day in the US today, which apparently was probably a bad idea to stream today, but here we are anyway. Has anyone voted today? Or voted pre-voted or whatever it's called? Good evening, Jay Dyer. Hello, Kagisho, and hello, Isabella. Hope you're all doing well. You mailed in your ballot last week. Nice. I'm Canadian, so I had no idea. Hello, Thomas. Hello, Ranks as well. All right. So the first puzzle we have here is hello. I'm always like hesitant to say the name because I always get it wrong. Pia Pietato. I don't know. I'm bad at names. Okay. So the first puzzle we have is Rock Rat Zero's puzzle, which he made for 500 subs, which was very sweet of him. I didn't ask anyone to do a 500 sub puzzle, but he did it anyway. It has German whispers and sandwich clues and X sums. So the outside clues are either these sandwich. Hello, Yoshi, and hello, Eric. Are either these sandwich emojis or the X emojis. And those indicate either sandwiches or X sums. Hello, Thomas, or Tomas. And it says that either the sandwich total is given by these cages or the first digit. And then the X sum is, I think, given by, well, let's read the rules. Okay, so hello, David Ratner. Civic Duty Day, yes, indeed. Go out and vote. Hello, Robert. Although it doesn't affect me, but vote anyway. I guess it affects the whole world if, depending upon who's elected in the US, but if a sandwich total is given outside the grid, the value n is the standard sandwich sum for that row or column, which would be the digits sandwiched between the 1 and 9 in the column. The value n is the sum of the digits in the cage. So it could either be like if these were 2 and 5, then the sandwich sum would have to be 7 in this row. So at some point we would have 1 and 9 somewhere, and we need a 7 between them, or some digits that sum to 7. So we could have that and a 3 and a 4, for example. That would be valid. If no cage is present, so in this case or in this case, then n is simply the first digit seen. So in that case, if this was a 7, then that 5 can't go on the 5. What 5? I feel slightly better from Friday. Thanks for asking. This could work as well. Hello, Nicholas and Dusan. My nose is still bothering me a little bit. Yes, those are German whispers as well. I think it says that at the beginning. Oh no. I thought it said that. Actually, it doesn't seem to say what they are. I think they're German whispers. I thought I read that somewhere, but it's actually nowhere. Oh, the line that looks like a 5 can't have a 5 because it's the German whispers. Right, okay. This is of course a 500 is what Ranks is saying. The 5 can't have a 5. That's funny. Okay, yes, so the X clues, 1 second. just saying that my nose is acting up, and of course my nose responds by acting up. So the X clues are, if an X clue is given outside the grid, then the value n is the standard X sum for that row or column. N is the first value seen, or the first digit seen from that clue. So, and the second digit is the X. So if we had a 9 here and then a 3, then these 3 digits would have to sum to 9. If you had a 7 here and a 2, then these 2 digits would have to sum to 7. We're pretty limited on what we can actually do with these X's because, of course, it's going to be the sum of a single digit total, which is definitely where we're going to start. So I think that's all the rules except for these lines. I'm assuming they're German whisper lines, which means that they have to have a difference of 5. Any neighboring digits have to have a difference of 5. So, for example, if this was a 1, this has to be at least a 6. It can't be a 5 because that's only a difference of 4. So it could be 6, 7, 8, or 9. Take your pick. And 2 things about German whispers lines that you need to know in general is that you can't put a 5 on them because then you need to put a 0. Unless you can put a 0 in the grid, of course. We have S cells and stuff like that. And you can't put a 10, of course, so you could never have 5 there. And the other thing you need to know is that it'll always oscillate from a low digit, so 1, 2, 3, or 4, and then a high digit, 6, 7, 8, or 9, because 1 can only go with 6 at the very lowest, and 9 can only go with 4 at the very highest. So it'll always oscillate between those two low, high parity. I'm sure this is all review. Hello, Melrog, or Malcolm, whichever you prefer. Thanks for the congrats. And we can immediately look at this cell and say that since this digit will be some digit between 1 and 9. Hello, Rockrat. Thank you for the puzzle. Hello, Ambrose. This digit will be some digit between the digits 1 and 9. It will have to be made up in 3 or 2 digits or 1 digit, but that would only work if it was the digit 1, and that would repeat the 1. So this digit, which is the number of digits that sum to it, will have to be 2 or 3, because it can't be 1, as we just discussed, and it can't be 4, because if it was 4, then it would add to 10 at least, with the minimum 1, 2, 3, and 4, and that's 10, and you can't put 10 in this cell. So this will be a 2 or 3, and this will also be a 2 or 3, which allows us to color these lines with high and low, so we can give all these cells a orange color and all these cells a blue color to indicate that the blue digits are low and the orange digits are high. Excuse me. Yes, hello, Rockrat. Are these indeed German whispers lines? I'm sure that now that we're putting them in as German whispers lines, if they're not, a bet cell. Let's think. What would be a good bet cell, Rockrat? I'll let the constructor choose. And of course, this cell can never be a 4, because then you'd have to do 4 in 2 cells, which would be double 2. So this has to be 5 to 9. This also has to be 5 to 9. If this was a 3, this would have to be 6 or greater, but it could be a 2 with a 5, for example, because then you'd have a 2-3 pair. Okay, so we know they're not 5s because they're on German whispers lines, of course. We just said there can't be any German whispers lines that have 5s on them, and they can't be 6s either because this is not a 1, and 6 on a German whispers line will have to go with 1 because that's the only digit that's 5 away. Okay. Yes, friendly reminder to like the stream. It does really help. I know Zeta's been really pushing this to like the stream. If you could like this stream as well as Zeta's stream whenever you're in there. And he says the bet cell is row 5, column 6. This one. I'll turn on the row and column labels as well. I turned those off for other purposes earlier this week. And if you want to give hints or help out during the solve, that's totally encouraged. You can definitely do that. As well, this digit is a single cell total, which will have to be 6, 7, 8, or 9, because it's a high digit. 4, 5, and 6 in box 9. Well, in box 9, we have this German Whispers line that's completely encapsulated, and you can't put a 6 here because then you'd have to surround it by double 1, and that would repeat the 1. And you can't put a 4 in this cell because then you have to surround it by double 9. Therefore, and you can't put 5 on here at all. So therefore, 4, 5, and 6 have to go in this cell, these cells. And the same can be said of box 6, of course. And I think that's Nicholas's point. That places 4, 5, and 6 in box 3 as well. And we have, yes, Malcolm, roping. We have roping. So since these cells are the same as these cells are the same as these cells, then we know that these cells in box 9 will have to go down here and will have to go up here in this box. So we have roping. So these cells are the same as these cells are the same as these cells. You can always say this if you have this pattern, you can always say that the things are completely roped in this way. Hello, Chip, and hello, Caravan. And Chameleon, hello as well. So we can color these lines is what Ranks is saying. We can color these two cells as being blue because these cells will go in here, so these will have to be blue because we're going to have to put 2 low digits in here, so then we can see that those have to be in these cells because they can't be next to each other. And as well, we can see that these cells are the same as these cells are the same as these cells, so there has to be 2 high digits in here. And as we can see, the parity goes like this, so we have to put those 2 high digits in those 2 cells because they can't go next to each other again. And what does that tell us about these cells? Well, I guess these cells have 2 low digits and 1 high digit. My brain went entropic for a second. What about this? It's not that interesting, I guess. Oh, they're all low digits in this column. So these 3 cells have to be from 5, 6, 7, and 8. Say 6, 7, 8, and 9. So we know that the 9 in this column is in one of these cells, and it can't be adjacent to the 1 because we have the sandwich total in this. I think row 1, column 3 can't be a 3. Definitely can't be a 3. Where does 4 go in column 3? That's a good idea. So in column 3, the 4 will have to be next to 2 9s. And those 2 9s can't go here, and they can't go here because then we would repeat the 9 in the row. So the 4 can't go in those 2 cells, and it can't go in this cell, and every other cell is either high or 5, so that has to be a 4. No worries, Nick. We figured out what row 1, column 3 is. And you're right, it couldn't be 6. So these can't be 9s anymore. And we know that can't be a 4 anymore. So we can write 1, 2, and 3 in here. Of course, there's a 1 in one of those 2 cells. Right, and then the sandwich in column 3 has to sum to 9, and it already has a 4 in it. If it had these 4 cells in it, if this was the 1 and it had these 4 cells in it, there's no way it's adding to 9. So this has to be a 1 and this has to be a 5 to add to 9. These 4 and 5 add to 9. So that's not a 1. And now we know that these digits can't be 6s. And where does 6 go in column 4 then? These are all the high digits. Those are 4 high digits. And we already know that 3 of them can't be 6. So that has to be a 6, which means that's going to be a 1. And that's not a 6. Hello, Carl. The cages are here. Maybe I can give a full view of the sandwich rules. No worries, Malcolm. The cages are the sandwich totals for that row, is essentially what it is. Let's look at the sandwich total for this row because the 9 will have to go somewhere over here, either here or here. So it's the 9 is in one of these two cells. And this is a low digit, which will have to be 2, 3, or 4. So what's the maximum that this can sum to? I guess 8 and 7, right? So that's 15. 15 we could make in these 4 cells. We could do that. Row 3, column 3 is a 5 for sure, yeah. Eric, you might be a few seconds behind. Row 3. You mean this digit? It's not a 2. It's not a like 20 something. It's a sum. So the digits in here sum to the thing. Just to clarify for anyone like Malarog who didn't understand, you know. Okay. So let's think here. So if this is 7, 8, then we'd need these cells to add to 15 as well. Because, or sorry, if these cells and these cells were the same total, then these cells would have to add to 15 because that would be 45 divided by 3. But that does work because 1 plus 9 plus 5 would be 15. Whereas if we had just these two cells equaled these two cells, well, that can't be a 5, we know that. If we had these two cells equal these two cells, then we have 2x plus 15 plus these two digits would add up to 45. My brain is telling me that that seems reasonable. Maybe not, but it seems reasonable to me, so not sure that's where we're supposed to look. Maybe we're supposed to look at this, because this one, if that was 3 digits, that would have to be 5 plus 5, which would be 10. That's too many. So that has to be a 2, that has to be a 3. So then we can pencil mark 5s in... Oh yeah, we can probably pencil mark a lot of 5s, right? Because there's these German whispers everywhere. We can pencil mark 5s over here, pencil mark 5s down here. That's definitely not a 5. Row 7, column... Yes, we can clear that for sure. So now this plus this has to equal this. Well, this digit has to be smaller than 2 smaller than this digit. And the only way we're going to make that work is with 6 and 8. So that has to be 6, 8, and 7. Hello, Andrew. So those are all done. Now this digit has to be 7 or 8 because it can't be 9. And this also has to be 7 or 8, but it can't be 7 because 7 and 3 is only a difference of 4, of course. So therefore, this digit will have to be either 2 or 3 because it can't be 4 because that would have to be next to 9. What about this one? If that was a 3, 3 plus 4 is already 7. Would need another 2 to get to 9. So this could be, well, this can't be 8 anymore, but it could be 2, 3, 4, 2. But there's always a 2 in one of these two cells, which means there's no 2 here, there's no 2 there. So I guess 2 in this box is in there. I don't know. 8 looks down column, yep, definitely looks down column 4. I'm an idiot. So this is a 2. So then that's a 2. So this digit plus this digit equals that, and that's not 7, so this can't be 9. That's a 7 and that's a 5. And that's a 4 and that's a 6. So 6 goes in one of these two cells. 5 goes over here. 9 in row 6, column 2. Oh, yes, because this is from 8 or 9, and it sees an 8, so that's a 9, of course. This can't be a 4, of course, and it needs to be a low digit. If it was a 4, then this would also be a 9, so that has to be a 2. This is of course an 8 because it sees 7, 9, and 6, and it's a high digit. So this is a 4, 5, and 6 triple again, which means this has a 4 in it, not a 4, 5, 6 triple because there's a 6 over here. That's not a 4. That's not a 5. Row 4, column 2 is now an 8. Yep, done. We did that. This is a 6, so that's not a 6. So we have a 4, 5 pair in the row. The row 6 sandwich is now useful? Probably. Because these add to either 9, 10, or 11. And we already have 11 in the sandwich, so that means that we need to stop it there because 11 is the maximum. So that is 11, and this is a 4, and this is a 5. Nice spot, Ambrose. And this has to be a 1 because then we have to stop the sandwich there. Row... Oh, yes, okay. Row 7 and 6 and column 3 need to be colored before... Oh, okay. You really want me to color all the digits? Okay. I guess I will. I guess if I have to. Okay, this can't be 1, 2, or sorry, 1, 3, or 4, so it has to be a 2. Hello, 11. You're not that late. This is just a very smooth puzzle. Highlight, I'm dead. Oh no. These are from 7, 4, 5, and 6. This one can't be 4, 5, or 6, so that is a 7. The way my brain works sometimes. Column 5 sandwich? Oh, I didn't even see there was a column 5 sandwich. So that means that where does the 9 go in this column? It can't go up here. It can't go right next to the 1. So either the 9 is here or it's in one of those two cells. But if the 9 was here... I'm not sure about that actually. Let's look at these two cells. These are an 8, 9. These are a 1, 3. So that has to be a 3. That has to be a 1. I guess we don't know anything about the 8, 9 then. Oh, yes we do because there's an 8 over here. So that's a 9, that's an 8. This is an 8, 9 as well, which is fixed now by this 9. So that's a 9 now, and now we can look at column 3 sandwich. You could have had a single digit filled because of the age. I'm not sure what you mean. This is now a 3 and a 1. Now 1 goes here because it's not in here. This is a 7. So this is a 2. That's not a 2. This is a 7 or an 8. I was hoping it was an 8, but I can't prove that now. So now we have... It's okay. It is on the lowest latency, but sometimes, you know, things still happen before they happen, you know. 1 second. Sorry, just giving you guys a chance to catch up. I can finish row 4. Yes, probably. 7 and 2, so that's a 7 and that's a 2, which means that's an 8. Which means that's not an 8. You can color that as being high. So now this digit's pretty restricted. It can't be a lot of things. No, it was my nose, actually. Row 9 and row 5. Oh, it can't be here because of the sandwich. The sandwich has to be at least, oh, a certain number of cells. So that's a 9, which is the bet. Oh, yeah. I was like, why is there a circle there? Oh, right. Okay. Um, it's okay. Uh, it's okay. It's not a big deal. Let's look at the sandwich in column 5 seems to be restricted now because this can't be a 9 anymore. So there's a 9 in one of these two cells, which doesn't seem particularly helpful. Although if that was a 9, the 1 would have to be over here. The 1 is over here in this row. Where's the 1 in this row? This row needs a single digit total. If that was, oh, this is definitely the 1 because this has to be a single digit total. So that's a 7. There we go. There we go. Right as Malrog suggested, yes. So these two are 5 and 8, which is placed. 5 and 8 go in. Which means, well, that's not a 5. But now there's 8 in the sandwich. So the 9 being here means these would have to add to 8. They can't be 1, 7. They can't be 2, 6. Could be 3, 5. No, they can't be 3, 5. So they don't have any options. So this 9 is not a 9. So that's a 9, which means that these two digits sum to the same as these two digits. So I think this is going to be, I think this has to be 3 and 4, doesn't it? Oh, 4 and 5 might work. So these three digits have to be 3, 4, and 5. But these two digits have to have a difference of 1. This one has to be 1 greater than this one. So this can't be 3, this can't be 5. Oh, that's a 3, 4, 5 triple. Oh, stop. Stop doing that. I'm gonna get the pencil again. uh, these digits are a 3, 4, 5 triple as well. Okay, what about the sandwich here? Because it looks like the sandwich is either going to be 8 and this digit, or it's going to be 8 this digit and another digit, but then the 1 will be in the sandwich total, which can be at most 10. But that would be 3 plus 4 plus 8, which is not 10. So this is a 1. So that's a 4 and that's a 4, which means the sandwich sums to 12, which it does because this is a 9 and a 3. This is a 5, now this is a 3. This is a 4 and this is a 5, and I don't know what this is. That's enough. That's a 6. That's a 4, that's a 6, that's a 5. That's a 3, that's a 5. That's not a 5. It's okay, Rockrat. You did your best. That's a 5, that's a 6, that's a 4. Okay, so it looks like these two digits are sort of what's going to finish out the puzzle because we've used all the other clues. So what's going on in this row? We have 2, 3, 8, and 7 left. This can't be 8 or 2. These, well, that one can't be 3 or 7. That one can't be 8 or 2. So we have a 3, 7 pair, which gives us a 2, 8 pair. Oh, for some reason I was thinking that these two had to add to these two, and I was like, that's never gonna work. But yeah, it'll work now. Uh, oh wait, no, that's never gonna work. Um, why was I trying to make that work anyway? I think this is 11 and 11. Yes, yes. Because if this is a 3, then this is a 7, and that's already 7. So this is definitely going to be 11 and 11. Very nice puzzle. It looks like it's going to finish off here. So that's a 6, brain, 1, and a 2, and a 7, and a 4, and oh, look! So surprising, this is a 9. But we're not done yet. We still have to color all the digits. So if you bet 9, you were thoroughly surprised by that outcome, I'm sure. Very, very smooth, definitely. And very cute. Thank you, Rockrat. That was a great puzzle. We'll color the 5s gray as well. Oh, I didn't get the 8s. Oh yeah, yeah, the German whispers, yeah. So color them green, yeah. Just ironically, you know. Okay, 5s are gray, yeah. It's like the classic like what color is chemistry, or what color is math? Or we were talking about yesterday, or was it yesterday? It might have been a couple of days ago in my D&D group. What color is like the different skills? Like what color is dexterity? What color is strength? What color is wisdom? Okay, let's just go straight into another puzzle. So let's go pick, puzzle pick, and I will put a poll in the chat for which puzzle you'd like to do. So the first one we have is Lovely by Laylo, and this was suggested a while ago by Laylo himself. He made it for his now fiance, but I think it was for their engagement. Is that correct, or was it because of their anniversary? I can't actually remember. The second one is Looking Glass by Logan the Wall, one of our patrons. If you want to support us on Patreon, look in the description for a link. And the final one is Vault Construction by The Kagi Show, which is the last person we interviewed in the Setter Spotlight series. Well, aside from me, of course, which was not really an interview. Well, sort of. All right, let's see here. We have 20 votes right now, 27 people in chat, and it's pretty even. So get your votes in because it's 35, 30, and 35. It's tied. The first one and the last one are tied. So get your votes in and we'll see whose puzzle we're going to do. Let's check out who got featured today on CTC. Let's see here. A chess master sets us a new puzzle. Interesting. Christian Koenig, CFK. Congrats, CFK. I think I recognize that name from the Discord. It looks like puzzle number 1 pulled out, and then puzzle number 2 pulled out again. We have 23 votes. We're still tied 35-35, puzzle 1 and puzzle 2. Okay, puzzle 1 has pulled ahead. with 38%. I'm ending the votes. Let's check out Malcolm's. Here, wait. We'll go to the puzzle that we're doing, and then we'll check out Malcolm's suggested. That's Looking Glass. Where's Lovely here? There's Lovely. Malcolm suggested coloring of the D&D things. Strength red, dexterity blue, wisdom purple, intelligence green, wisdom orange, charisma yellow. I don't think I agree with almost any of those except maybe charisma. Maybe intelligence green. Yeah, I could see intelligence green. Yeah, I'm gonna shrink the grid just a little bit. Bring him down slightly so that we can see that. Oh yeah, and then the other side too, we need to see. There we go. No, I don't think I had that script ranks. Is that a script for OBS or is that a script for CTC? I'll ping Lalo to let him know we're doing his puzzle. I see. Oh, interesting. I might get that. Definitely not during the stream, though. I'll have to set up everything again. Okay. So we have German whispers, Renban lines, thermometers, and consecutive croppy dots. The red lines are just for decoration purposes. What's Poos? Should I look that up? What's Poos? Is that a color? It's an interesting color. It is French for flea, apparently, because there you go. All right, so German Whispers lines, we had them in the last one. They need to be, hello, Lima. They need to be a difference of 5. So if I put a 1 here, I need at least a 6. I can't have a 5 because that's difference 4. So I could have a 7 or an 8 or a 9 next to the 1, but not anything 5 or lower. And of course that applies for every other digit. They have a difference of 5 consecutive. On the line, a Renban line, which is these pink ones, or these purple ones, if you prefer purple over pink, or what color you see. They have to be consecutive in any order. So I could do 1, 2, 3 here, or I could do 1, 2, 3. They don't have to be in order. They just have to be consecutive. So they could be 4, 6, and 5, or whatever consecutive string of digits. And those are the same as these and these. What color do I think chartreuse is? I think maybe like a brown, is it? Is it a brown? Oh no, it's greenish yellow. Green was my sort of second idea, but I wasn't sure. Okay, interesting. Anyways, aside from that, the thermometers have to increase from the bulb end. So if this is a 4, 5, 6, 7, they don't have to be in order. So this could be a 7, 8, 9, but then you wouldn't be able to fill out these because they'd be bigger than 9. But can't be in there. Interesting. We have another weigh-in from ranks saying strength red, dexterity yellow, con brown, intelligence blue, wisdom pink, and charisma violet. Interesting. Stumping me with obscure color names. That would be interesting. Maybe interesting, but probably very boring because I probably get them all wrong. Yeah, it is a weird name that people tend to think. Yeah, I think people would tend to think that it's a brown or red color, but it's yellowish green. And then these consecutive dots, they have to be consecutive. So like sort of like the Renband, but more like a 2-cell Renband. So this digit has to be consecutive with this digit. So it could be 2 and 1, or 2 and 3, or 3 and 2, etc., etc. And yeah, I think box 5 is a good place to start because this either goes 1, 2, 3, 4, 5, 6, 6, 7, 8, 9, or the reverse. So we can always put the 5 here. We can always say that these two cells are a 1, 9, these two cells are a 2, 8, these two cells are, oh, that's the wrong cell. These two cells are 3, 7, and these two cells are going to be a 4, 6 because it's either that way or the other way around. Sorry. I hate when your nose gets that like weird tickly feeling. Ugh. Anyways, so this set of digits, these are all consecutive with each other, but also this one is consecutive with this one. So this digit is going to have to be a 1 or a 9 because this essentially forms 8 consecutive digits. And if you think about the digits 1 to 9 in a row, and then you take off either 1 from either end, you're going to have obviously 1 and 9 left over. Hello, Math Pesto. Hello, Eline. So then this digit right here will either have to be a 1, 2, 8, or 9 because it needs to be the last digit other than the other digit that's not on this consecutive sequence. It needs to be consecutive, but not consecutive with any of the other digits. So then this will have to be, of course, oh yes, this nice 2-8 pair in the column rules out 2-8 from there, meaning that this is a 1-9 pair, and this is, of course, consecutive with the 1-9, which means it's a 2-8. And we also have this 1-9 pair in this column as well. Interesting. So there's definitely a 1-1-9 over here and 1-1-9 over here. Oh, and there's a 2-8 over here, but it can't go on here with a 1-9. But it could just be there. Anyways, I'm getting distracted. This thermo is 7 cells long, which means that it only has 3 options. And this, no. The 1-9 is not very helpful in this case. But it is slightly helpful for this digit. Because this digit now can't be a 1-9. Which means that this digit can't be a 4-6. Thermos in box 7. Yeah, that's a good place to look probably. So let's look at these ones. So these ones have to be 3 so these any three digits on a Renband will have to be divisible by 3. So for example, 1, 2, and 3 adds up to 6. It's divisible by 3. And the reason why you know this is if you imagine a Renban in 3 cells, then you can always define a middle digit on that Renban, and then the digit below it will be x minus 1, and the digit above it will be x plus 1. Then if you add up those digits x, x minus 1, and x plus 1, the plus 1 and minus 1 will cancel out, and you'll have 3x. So it'll always be divisible by 3. And 45, which is the digits 1 to 9 all added up, is also divisible by 3. So that means that in this box, these are divisible by 3, these are divisible by 3, and these are divisible by 3, so these are also divisible by 3. Which I'm not sure will be super helpful, but it's something to note. 1 has to go on row 9. Cannot be on a Renban. Yeah, okay, so if 1 was here, for example, then this would have to be a 2 and a 3, because 1 is only consecutive with 2, and then 2 will have to go to 3 above it. But then once there's a 2 here, you can't put anything lower than a 2 here. So in fact, 1 has to be in one of these 3 cells, which means that the other 2 cells have to either add up to 5. Well, you have to get to a multiple of 3, right? So ditto 9 in row 7. Are you sure about that? I mean, 9 definitely can't go here. 9 cannot go in row 8. 9 can't go on the bulbs. But I think 9 can go here. If 2 was not at the bottom, if 2 was here, this would have to be 3 and 4, and then you'd only have one digit below 2. So you're right, 2 also has to be in the bottom row, which means that we either have 1, 2, 3, or we have 1, 2, 6, or we have 1, 2, 9. Because 1 and 2 already add up to 3, which is divisible by 3, so we have to add a digit which is also divisible by 3. Which means, well, these obviously can't be 9s. We also know that 1 is not in here. That's not very helpful. Okay, so if this was no 6 in the bulbs, because if it was 6, then this would need to be 7, 8, 8, 9. But 8, 9 would have to go with 7, 8, 9. And that would mean that this digit has no value. So the 6s also can't go in the bulbs. So either the bulbs are 1, 2. Oh my word. Eric McGee has put a lot of thought into this. Yes. So this is 1, 2, or 3. If we knew 9 was up here, then it would be with 7 and 8, of course. So if this is 1, 2, 3, or 1, 2, 6, this is 7, 8, 9. If this is a 9, do we know that this has to be 8, 7, 6? If this is a 9, I definitely can't put an 8 here. Right, so if this is a 9, this is a 1, 2 pair, which means that the 3 will have to go in here with 3, 4, 5, so this will be 6, 7, 8. So this is 6, 7, 8, or 9, which means that 8 and 7 always go up here. I don't think it forces 9 onto the Renban. I think 9 can still go down here. I don't see a reason why it can't. But I think 4 and 5 are always in there because we've ruled it out of every single other place. And this is a 1, 2, 3, 4, 5, 6 cell Renban, which needs to have 4 and 5 on it, and those can't go in in those cells. So 4 and 5 in this box are in 2 of those cells, or 2 of those 3 cells, yeah. 2 of those 3 cells. If that was a 4, 5, 6 triple, then we would know this is a 4, 5, 6 on the outsides, right? What if this was a 3, 4, 5 triple? Wouldn't we also? No, because you could go 7, 8, 9, 4, 5, 6 and not have a 3 on the line. What are the outies? I guess 1, 2, 3, 7, 8, 9. Oh, 1, 2, 3, 7, 8, 9. That's really interesting, actually. Because if you do 1, 2, 3, 7, 8, 9, these can't be 1 or 2. Which means there is a 1 or a 2 on here. This can't be 7, 8. So this cell can't be both 1 and 2. So then one of these cells will have to be either 1 or 2, which means there is a 3 on the line. That's cool. So there definitely is a 3 on the line, which means there's no 9 on the line. Because if there was a 9 on the line, then yeah. And of course there has to be a 2, because if there's a 1 or a 2, if there's a 1, then there's a 2. And if there's no 1, we already know there's 1 or 2, so there is 2. So what do we know from there? Well, we know either 1 or 9 is off the line. Huh. Okay, so I think this 3 thing means that whether, I think this either has to be 3, 4, 5 or 4, 5, 6. Is that correct? If this is a digit which is not 3, if this is a 6, this is 7, 8, 9, which means this has to be 3, 4, 5. If this is a 9, this is 6, 7, 8, which means this is 3, 4, 5. If this is a 3 or a 3 anywhere here, then this is 4, 5, 6. So that this is always 3, 4, 5, or 6, which means these are always 3, 4, 5, and 6 because they can't go on here, and 3, 4, 5, and 6 need to live on this line. Very cool. 9 Jovies in box 7, and 9 puts 9. Yes, 9 is in one of these 2 cells for sure. So then, what does that tell us? Well, we know that there is a 3, 4, 5, and 6. Yes, this is Sudoku. We are solving Sudoku with some variant rules. Welcome if you're new. Yeah, there are thermometers and Renbans and German whispers. Thermometers have to increase from the bulb end. High-low parity on Kropke in row 5? Yeah, maybe. What are they saying? Row 3, column 9. Maybe explain that point a little bit, Alima. Only 2 places for 2 in, yeah, 2 can only go in these 2 places in row 7 because it needs to go somewhere in here. Hello, Creakers, thank you. 8 is not on the line in box 9? How do you know that? Oh, one of 7 and 8 is not on the line. And if 7 wasn't on the line, then yeah, okay, so 7 definitely is on the line because, yeah, because if we had 7 off the line, then we would need 8 on the line, but not 7. That's impossible because, yeah, okay, so this is 8, 9. This is a 1. That means that's not a 9, and we finally have our 7, 8, 9 triple that Nicholas has been saying forever. Which means that 1 is forced in the same positions as 9 in this row. So that's a 1, 9 pair. Which means we have our 1s and 9s for these columns. Row 8, 9, column 6. Yeah, no matter what goes in here, it's definitely going to fix the parity of this. 8 in box 8 can't go in there, so must go there. Can't be with a 9, so must be with a 7. So now we know this is a 3, 2, 1, 4, 6, 7, 8, and 9. That's a 1, that's a 9, that's a 1, that's a 9. Awesome spot, Ambrose. That's an 8. Okay. There's a 7 in one of these two cells. It's a cool puzzle. Okay, what do we need to put in these 3 cells? We need 2s, 5s, and 6s. What about this? That digit is very constrained. That's either a 4 or a high digit. So this is either a 9 or a low digit, and it can't be a 4. Thermo in box 3 is quite limited. Well, that can't be an 8 anymore. Okay, let's just 1, 2, 3. Oh, whoopsie. That can't be an 8. So that can't be a 7, so that can't be a 6. 7 box. Too many things. You can place 1 in box 3. Yes, 1 in box 3 is placed now here. Row 2, column 9. Yeah, I guess that's high by colors the whisper. Well, these 3 are high. I'm not sure if we have enough high digits. Oh, box 1 whisper. Ah, there's 2 digits here, which have to be low now. So these have to be high. So these are from 6, 7, 8. That can't be a 6. These are from 1, 2, 3, 4, except they can't be 1s. So neither of these can be 6s. So we have a 2, 3, 4 triple, which gives us a 5, which gives us a 6 and a 7. That's now an 8, 9 pair, which gives us all the high digits in the column, which means this is low, which means this is high, which means this is low, and this is high. That's not a 1, so that's not a 6. Yeah, that can't be a 4, of course. So this is a 4 because there's a 2, 3 pair in the row. So that's a 9, and this is not a 9. So that's not a 4 anymore. And that's not a 9 anymore. So there is a 9 in one of these two cells. Okay. There's no 4 here or 6 there. Row 5 prop key. That looks interesting. That can't have any of those digits, so it has to be from 7, 8, 9, or 1, 2, 3. But it can't be a 2, 3. And it can't be a 1, 2. So it is from 7, 8, 9, which means that this digit is from 1, 2, 3. Which gives us a 1, 2, 3 triple in the column, which means that's not a 3. Last digit in row 2, yep, that's a 6. So that's not, those aren't 6s, yes. Okay, so this is a 1, 2, 3 triple, which means that's not 3s, which means we can erase all these wild pencil marks. That's not a 3, which means that these digits are 4, 5, and 6. That's not a 5, so that's not a 5, because there's a 5 in these two cells. 9 in box 4 is placed, apparently. That definitely has to go there, because if it went on the line, then this would have no value. So that's an 8. So that's a 7. This is a 1 and a 2. That is not a 7. Lots of things going on. Can't be there? Okay, that's a 7. That's an 8. That's a 9. 1 second, I'm going to blow my nose. Anyways, I find it very unlikely this is a 1 or even a 2, because if it was, then you need a 1, 2, and 3 in here, but these can't be 1, 2, or 3, and that can't be 1, 2, or 3, so that has to be a 3. Oh, and there's also a 1, 2 in the row. There's also a 1, 2 in the row. So that's a 2, that's a 1. Okay, so what about these digits? Well, this is a 1, 2. You know that. Why do easy things when you can just do the hard ones? This is a 3, because there's a 2 in the row. I am seeing things like 2s in the row now. That's not a 4 anymore. I don't know what letter or number I was saying there. 2, 3, and 7 go in those cells. That's not a 7. That's not a 2 or a 3. So that is a 7. It's the 2, 3 pair. 2 in column 9. Yeah, that goes right there. So that's a 2. That's a 3. So it needs to be 3s in here. Oh, this 7 here is on a Ren band, and this is an 8, 9. So this needs to be 6 and 8. And that needs to be, oh no, it could be 6 and 5. No, it can't be 6 and 5 because there's a 5 in the column. So this is a 9, and this is 8 and 6. And that fixes this as a 4, that fixes this as a 5, and this is, that's not what I meant to do at all. That's a 6, that's a 2. These are not 2s. That's definitely not a 2. There's a 2 in one of these two cells now. 5 in row 9 apparently is fixed. It's right there. So in this box, we need 4s, 6s. The 6 goes right there. The 4 and 3 are still not resolved, though. I meant to do that in middles. The 6, 8 is resolved by this 8, of course. Duh. The 6 goes in one of those two cells. Not useful. Oh, this 6 and 5 are resolved. That's a 5. That's a 6 by that 6. This 5 and 5 should... Nope. Doesn't place the 5. What is this? 2 and 9 in the column. So that's an 8. That's a 9. That's an 8. So this digit should be given. That's a 5. And these two digits we know are 4 and 3. So that's a 4. That's a 3. This is a 4. 5, 6, and 7. So that's a 5 because of the 6 and 7. So that's a 5. Which gives us a 5 in box 7 and a 4 and a 6. Which means that it's funny how these became completely useless once we sort of filled everything in. This is a 6 now. This is a 7. We know this is a 7, 8 now? Oh, this 8 fixes it. That's a 7. That's a 7. This is an 8. Oh, that's a 9, so that's a 2, and that's a 9, as Nicholas points out. That's a 2. I'm just going to uncolor those so no one complains that I didn't color. I only colored a couple cells, so. This is 3 and 4, and the 4 here places it as black, apparently. That's a 3 and that's a 4, so that's a 3 and that's a 4. These two cells are a 1, which is placed, and a 3, which is placed. That's 3 and 2, 2 and 1. Done! That was a great puzzle. Had a lot of interesting logic. It didn't feel that busy, actually. I thought it was gonna feel quite a bit busier than it did. That's a beautiful puzzle to give here. That's a lovely puzzle to give to your spouse or fiance or something like that. I can't remember the exact story. Well, I'm feeling oh yeah, chat was definitely all over that puzzle. I'm feeling good, except for my nose apparently doesn't feel 100%, but I'm feeling. Let's go for a second one. Let's go for another one. We'll have to put in a new puzzle number 1. We have First Hidden Skyscrapers by Nell. And we'll start a poll for which puzzle next. Sorry, taking the moment when you guys are voting to blow my nose and get a drink of water. All right, let's see what's the poll going on here. It seems like a lot of people want us to go for the vault construction, which I've heard is an excellent puzzle. I haven't watched the video. I almost watched it, the feature on CTC, when I was going to interview Kagisho, but I decided against it. I figured I'd let it sit there for a little while. Okay, we almost have all the votes in, and it seems to be an overwhelming majority for the vault construction. So have fun voting, Ambrose. Yes, it is X out of 5 for difficulty. And hello, Miter, I want to say. I don't think I've seen you around before. Let's look here. We can bring, if we can bring the, you know, if the OBS could just, you know, work. Come on, OBS, you can do it. You've got this. We all believe in you. Come on. This is probably, they updated it recently, so. It's probably some, yeah, there we go. Finally. Had to reset a bunch of things. Yes, I recommend not updating it, Rex, because it seems to be quite obnoxious right now. Now with even more efficient inefficiencies, yes. I'll go ahead and ping the Kagisho, let him know that we're the vault construction. All right, so in this puzzle, I tested, I think, an early version of this puzzle, but it's definitely gone through a lot of iterations. And I know Zeno had helped the Kagisho sort of figure out some things with the vault construction, and then I think they posted like it's this impossible or miracle vault construction, and then Kagisho did another work on it, and then found this grid, which apparently is very good puzzle. Is a very good puzzle. So it says normal chaos construction rules apply. Pink cages are vaults. Digits may repeat within a vault, which I'd hope so, because this seems to be a quite large vault, and if we couldn't repeat digits in it, I think we'd have quite a bit of trouble with that. The largest digit in any given vault is equal to the number of distinct regions passing through the vault. Oh, I skipped something. Any digits within a vault may not appear in any cells orthogonally adjacent to that vault. So for example, this 3 is of course orthogonally adjacent to this vault. So that means that in all of these, what is this, 7, 10, 13 cells, there are no 3s. And this 6 is next to this vault, which means that there are no 6s in these 3 cells. Well, the only one that could be a 6 is this one, but now we know it's not a 6 because there's a 6 next to the vault. I'm not sure why it's called vault. Trying to like think, is there some reason why it would be called vault? Is there a good bet cell? I think we missed bet cell on the lovely puzzle, but is there a good bet cell Kagisho that we should go with on this puzzle? Row 2, column 8. Okay. The last bet cell was revealed quite early. Oh, no? Okay. Hold your bets. Hold your bets. Row 1, column 5. Oh, that's the opposite, or the transpose. Row 1, column 5 is this one. Okay, place your bets. Place your bets. I wouldn't bet 3 or 6 today. I definitely wouldn't bet 3 or 6. If you want double your money, you can bet for a color. You bet 3. Kagisho's not winning today. Not feeling this time. Well, it doesn't say that digits can't repeat in rows or columns, so. But they can. Digits can't repeat in rows and columns. Okay, so we have to figure out, okay, so since the largest digit in any given vault is equal to the number of distinct regions passing through that vault. Well, I'm pretty sure that this is a 1, because I don't think there's more than one distinct region going to pass through this vault, and the largest number of distinct regions passing through the vault of one cell is definitely going to be 1. Similarly, this will definitely be 1. And similarly, in this cage, and this cage, and this cage, we are limited, well, actually, and also this cage, we are limited by the size of this vault, so that we have to keep the highest digit below the number of cells in that vault. So for example, in this 5-cell vault, we can't have a digit higher than 5 because then we would have more than 5 regions within less than that many cells, which is impossible. So there's either a 2 in here or double 1. Well, I'm pretty sure that there's not double 1 in here. So there's going to be a 2 in here and a 1, and it's going to belong to 2 different regions, which means we have to have, I'm going to use green, we have to have a break between those two. And this region, of course, has to extend to here at least. Does that mean that the large region at the bottom can't have a 9, assuming that all regions are size 9? The large region at the bottom, this one? Yes, it can't have a 9 because there's a 9 next to it. It also can't have a 3. And we're gonna have other digits which can't go in here because all of these digits, which are orthogonally adjacent to this vault, cannot appear in the vault. But note specifically these 3 digits and the 3, well, there are going to have to be at least 4 digits in this column which cannot appear in this vault. So at least 4 digits can't appear in here. So we can have at most 5 unique digits within this 13-cell region, and we have to take every digit. We have to have a digit in every single cell, of course. So that's going to be difficult. Is column 2 a... Oh, wait. Yes. These 3 cells can't have digits higher than 4, and they can't have digits... they can't have 1, so they have to be 2, 3, and 4. And this digit can't be lower than 5, and it can't be 2, 3, 4, or 1. So it has to be a 5. And then we can also pencil mark this as 1, 2, 3. We can also pencil mark this as 1, 2, 3, 4. Which means we have a quadruple here. Which means these digits have to be from 5, 6, 7, 8, 9. That can't be a 9. Yes, there's an invisible 3 in column 4, but that doesn't mean that this has to be a 3 because digits could repeat in cages, so these 2 digits could be the same one. These 4 digits have to be from 1, 2, 3, 4, and 5. These obviously can't be 5s, and this can't be a 3. This can't be 1 or 2 because of this. Okay. Since there is a 5 in here, that means every single digit in here has to belong to a separate region. Similarly, with the 4 cage, we know that since there is a 4 in this 2, 3, 4 triple, we know that every single cell in this cage has to belong to a different region. So this will have to get out. And they're distinct regions, so we know they're all different from each other. So this one will have to get out from either the top or the bottom. Row 9 or column 9. Yeah, this can't be a 9 because of the 9 next to the cage. And either 1 or 2 cannot go in the cage, but we don't know which one. Yeah, maybe black lines will stand out a bit more. I'm gonna turn on edge only. Ugh. Okay, this digit can get at most 6 cells below it. So if it doesn't come up at all, let's say we draw this line, right? Then this will have to come down. It can't come into this cell because those are all distinct regions. So it'll have to come through here. and then it can't come into any of these cells because they all have to be distinct regions, which means it has to take these cells, which are 7 cells at most. So one more than that, but yes, it has to come up at least one. At least 2 actually, because it can't take this cell. Why can't it escape to the right to here? Because this has to be a different region. And it can't escape out of here because these all have to be different regions from each other, distinct regions. It can't get out of the bottom because this is also segmented. And in this case, this doesn't have to be a 3, so we don't have to segment this 3 cell in the same way, I don't think. There definitely has to be at least one border in here. But I think we could have this be the border, and these 2 cells belong to the same thing. We definitely can't have this cell and this cell belong to the same thing, though, because those would have to either be different values, which mean this has to be a 3, or they would be the same value and they would repeat in the region. The 5 has to go up. Oh yes, for sure. This 5, if it went down, then it would be trapped. So of course it has to go up, which means it takes this cell, and it can't go this way. Well, it could go this way, but only one cell, so it has to go that way. Oh, sorry, red. Which means we can draw a border in here, and it also has to continue. Well, yes, it does have to continue, I think, because that would be 9 cells, and that would even trap this, right? Well, this has to be blue. Yes, this definitely has to be blue. If this wasn't blue, then it would have to try to escape down here, and that would mean it has to join one of these 2, and that would violate the rules because these all have to be distinct regions. This has to get out as well. This has to be red. Oh, sorry, not that one, just this one. These also have to get out, right? Yeah, those will also have to get out. And again. And this will have to get out. And again, because this will only have 4 cells, so it needs to take at least 5 cells out here. Have a good one. Yeah, good thing we don't have a toroidal grid. The place 5 has to go up. Oh yes, so yeah. Carl, you're way ahead of me. Yes, green needs to grow at least 1 more. And I think that's as far as we can push this, right? Because this could take another 4 cells here and then be full. So let's think here. We've now come into this region and then into this thing twice. One of the purple cells is 9. Interesting. For row 7? Oh, 9 in row 7, right. 9 in row 7 can't go in any of those cells and can't go in any of those cells, so one of these 2 cells is 9. Good spot, Carl. I don't know. Yeah, I don't know why I didn't realize that. Says that 7 and 8 have to be in the vault. 7 or 8, yes. So in this row, only 1 digit can go in here. So at least out of these 4 digits, 4 of them are in the vault, which means that 4 of 1, 2, 3, 4, 6, 7, 8 is in the vault, and 1 of 6, 7, 8 can be outside the vault. So either 6, 7, oh wait. No, this could have a 1, 2, 3, 4 out here as well. Yes, 3 is not in the vault, right? So we definitely know that 4 digits over here are in the vault, and the 9 is not in the vault. How many digits? So that's 4 of the digits that will be in the vault. We don't need 5 digits in the vault. We can have 5 digits in the vault at least. We could have 4 digits in the vault. That is possible. Very unlikely, but still possible. Let's change this red to like a gray or something. Yes, the vault will need to have at least 7 regions because the best we could do would be putting an 8 and 9 over here. So best we could do would be putting an 8 and 9 over here. So we need to have at least 7 regions in this 13 cell vault. But we have 1, 2, we're definitely going to have this one. It's easy to get these two. So that's 1, 2, 3, 4, 5. There's no way we can get this one over there. That's 5 plus another 4. That doesn't work. We know this is a region. We can label that green. And that would mean 2, 3, 4, 5, 6, 7, 8. So if all of these regions are unique and touch this, then we have our 7 regions. Hello, Niverio. Row 1. Well, I definitely think nothing can get there, because this region is the closest one, and that would need 3, 4, 5, 6, 7, 8, 9. I can't get there. So that's definitely another region, right? But does that mean... But I'm not sure if this region is necessarily different from, say, orange. Yeah, gray is not necessarily... So these colors represent the regions that we know are distinct from each other. Unless this could join with that, maybe. No, that's too many cells. Yeah, that's too many cells. That's 10. So these are all distinct. We know that. So if these are all distinct, which we know to be true, then either they all everything but blue touches this, and there's a different region somewhere else. Or there's a new region in here. And one of them doesn't touch this. Well, this one touching that is quite difficult. 1, 2, 3, 4, 5, 6, 7, 8. Not that difficult, I guess. Although this one touching that and leaving enough space down here for all these is quite difficult. The big vault needs at least 7 regions to touch it, because if you make this an 8, 9, that is the best you could do with 7 and then whatever. So 6 and 7 would need to be in there. So that's the best you could do. So at least 7 regions. This seems very familiar. Are you sure I didn't test this, Kagisho? This isn't a 3. I'm surprised no one has commented on that. Okay. Because I do remember getting to this point and saying, I'm pretty sure that this one can't get over here because then there would be too much space left up here. Something like that. Let's see here. So this, if this one takes this cell or this cell, we're getting there, I think. 8 regions seems very difficult. I'm just thinking if this one could touch this at all. So let's say we did something like this. Then like how many, because we can fit, so there's 4 extra cells that we could do with this, right? So that would be 4, and then give me another 9 cells for the extra region, and then, but then this would also have to touch there. So this is just ludicrous. Yeah, this is just insane. This touching this is just insane. It makes it worse, Nicholas, if it touches that. If it touches that, it makes it even worse. Because then, let's say that we fill out our two regions up here with these 3x3 boxes, then blue somehow has to fill all this space. And that's not going to work. And even then, we would only have 6 regions touching it. We wouldn't even have 7 regions touching it. So, so that means that this region cannot touch this vault ever. And if this region can't touch this vault ever, which I believe is true because I tried to give it as much space up here as possible with touching this, and I don't think it can. So that means that this region and this region do not touch this, which means every other region, which means this region, this region, this region, this region, this region, and this region, row 6, column 7. So if I try to do this, Andrew, then I need to fill out so much space up here. There's just, the problem, Andrew, is that there's too much space up here. If I bring this across, it just doesn't work. I need to fill too much space up here. And I only have 1 extra region. Yes, it'll definitely trap these regions because this has too much space. So then I'm fairly confident that this green cannot touch this. Yeah, where would yellow and red and purple and everything go? They wouldn't be able to grow. Yeah, the other way to put it is there's not enough space down here to put the other 8 regions, or this would only be 6 regions, but yeah. Um, but essentially, if you make this, if you make any sort of wall here at all, then there's just too much space up here. So you can't fill it. There's just no way. Anyways, so since this green region and this blue region cannot touch the vault, so therefore the vault needs to have every other single region touching it, which means this black one needs to touch it, this yellow one needs to touch it, and the new one, which we haven't even found, needs to touch it. And the vault can't have 8s in it, so we now know this is 8, 9. And we know these can't be 8s. So right, and the vault does have 6 and 7 in it, so these can't be 6 or 7. So therefore, well, I'm still concerned about this one touching it. Because this one needs to leave room for the red to touch it. Because red needs to touch this. Actually, how does red touch this? That's a good question. The vault has a 6 and a 7 in it because in this row, the 6 and 7 have to be in the vault. That's just it. Yeah. So how does red touch this? Because red does not touch this cell, because that would block off pink from ever touching it. So red can either touch this cell, or this cell. Yeah, maybe we think about purple. If purple was to not touch it here, if purple tried to do that, then red would have to come over here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is the best it could do. Then yellow would have to come up here. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that right? No, that's wrong. That is 9. Andrew Sakis was onto something earlier. I don't see a comment by Andrew Sakis. There are only 7 cells on the large vault that can escape up or left, and you cannot have more than one region that does not escape. Right, right. So minimum, that's a good point, Carl. Even if purple tries not to take this cell, it still does have to take this cell because red can only get to there by doing that, which it has to do to allow yellow to get there. So pink always takes this cell, which means which means orange has to grow, which means green has to grow, which means green has to grow up, which means orange has to grow up, which means that red can't just come over here. Because pink is actually very much trapped. Oh, wait, what? Oh, sorry, green doesn't have to grow because it could take cells over here. Sorry. Green already touched the wall. Actually, let's look back at that for a second because what I just did is really broken. Because pink has to get out of here, right? So if pink has to get out of here, it has to do something like this, which means that this has to get over its 5-cell hump, which it's never going to do. Which means that if green grows here and here, therefore, then that does not work. So that means green has to take at least 1 cell over here. I think probably at least 2 cells. Oh, that's too bad, Andrew. I'm sorry about your power. Look at where row 9 connects to. So row 9 comes out of here, right? I'm not sure about that. Can't be pink or green. 2, 3, 4, 5, 6, 7, 8, 9. Then this is 8 times 2, which is not enough for 2 regions. So yeah, it can't be pink. And obviously it can't be green because green would have to come out here. So then it's either our new region or it's orange. Not sure which. But I do know that green can only take these cells, which means it needs 2 more cells over here. Yeah, I'm not sure which 2 cells though, because I think it could take any 2 cells. Let's go back to thinking about red and purple's debate on how they get out of here. Row 5, column 4 is a 3. Then we would know that this is split up. What color would be row 5, column 5? That would have to be the new color, right? Oh no. It could be like that or something. Yeah, that would work. With this being red, that would actually work. Sorry. Row 9, column 1. Oh, yeah. If green didn't take row 9, column 1, then it would have to take these 2 cells, which would mean that this is trapped. So it does have to take that, for sure. If gray takes the 9... Paths out of the big vault. Yeah, for sure, the paths out of the big vault have been pretty constricted. I mean, so we need, how many regions do we need? We have 3 regions that touch it right now. We need 4 more, and there are only 4 exits. So all of these exits need to be distinct regions. Yeah, that is true. Because this thing can't take enough cells down here without exiting. So that means the lowest one has to be red, the next lowest one has to be yellow. That's a fact. Row 7, column 9 is not an exit because that doesn't, yeah, that won't work. But if gray doesn't exit, Andrew, if gray doesn't exit, it either has to be orange, which doesn't help, right? Or it can't get enough digits down here, and it can't get the digits 1 to 9 is the other part, because it can't get a 3 ever if it doesn't exit. Row 5. If it comes into row 5 at all, then it has exited. If it takes those cells, Nicholas, then it's actually just broken, because then we can't even get 4 regions in here. Let's say gray takes these 2 cells, and then red takes that, and yellow takes that. You're never going to get black in here, and you're never going to get to 7 regions. So we need to take red, yellow. There's no other way. One of these has to be the new region, and one of them has to be black. Because we can't fit a new region in between red and yellow or below it, I don't think. Unless this could somehow get, I mean, if it comes, maybe this, okay, this is definitely red. This is red for sure. I'm not sure about that being yellow, actually. I think one of these is definitely black, and one of these 2 is yellow. Because if that was yellow, then black wouldn't be able to get there. But I think maybe this little gray could get in there somehow, and then yellow could get there. I think that is somehow possible. Red, though, red is suspect now. Because red only takes 1 vault cell. So how many cells can red take up here to allow yellow over? Okay, so currently minimum red is 6 cells. So it needs to take 3 cells, and it could take 1 cell out here. It can't take 2 cells down here because green needs at least 1 of these cells. We have already established this. Green can't come up here because then it traps pink. So red needs to take, if red takes 1 cell down here, then it needs at least 2 cells in row 5. I think Kagisho is hinting at the fact that I can only put 5 digits in here. 5 unique digits. Wait. Wait. This is it. This is it. This is it. I can only put 5 unique digits in here. So if pink took all of its digits in here, all the rest of them, then it'd be screwed because then it only has 3 digits out here. So pink either needs to take this digit or it would need to come through the 9, and it already has a 9. So pink takes that digit. I'm fairly certain. So then red has to come up. So then yellow has to come up. And now red, 1, 2, 3, 4, 5, 6, 7, 8. Could maybe, no, it can't come up again. Red definitely cannot come up again. That is a boundary for red. Oh, no. It could come up, but then, wait, no. If yellow had to come up here, that's too far. That's too far. That's way too far. That is way too far. So that is definitely yellow. One, 2, 3, 4, 5, 6, 7, 8, 9. This is forced. Yellow has to do that and take one of those 2 cells. And then red has to do that and take one of these cells. Green has to take that. Green has to take that. Orange has to take this. That's all forced. What's this? This is 5. So orange takes one of these. Pink has to get a lot of more cells. That's 5. So it needs to take 2 more cells out of here. And orange needs 1 cell. So that's orange. Those are yellow. Or those are pink. This is definitely yellow. And this is going to be the black in the other one. But if the other one was in here and black was over here, the other one would be 5 cells at most. So the other one is not there. The other one will have to be over here. We'll make that orange. This will be black. Pink needs a 3 is Rank's point, making that a 3, because these can't be 3s because it's a vault that has no 3. So that means that the vault does have 5 digits, and they're the exact 5 digits that are in here. So it does have a 5, which means that's not a 5. So that is not 8 or 9. Wait, don't isolate. Oh yeah, that doesn't have to be. That doesn't have to be orange. That's definitely green. That's definitely blue. Sick puzzle, by the way. Hope all that made sense. Why it was forced like that. This one is not a 3 because then we would have to have 3 divisions here. So therefore, these are the same digit. Oh, that's not a 2. That's not a 3. That's not a 3. Whew. Getting all worked up here. 3 can't touch the vault of size 5. Yes, okay, if this was a 3, then that would be broken. So that needs to be a 4, which means there is no 4 in this vault. Sorry, no 4. So there is a 5, which goes there. 1, 2 pair in row 5 already. Yes, 1, 2 pair in row 5, so that's not 1, 2, that's not 1, 2. So that's a 3, that's a 4. And that's a 2. Yeah, forgot all about that vault. Um, this digit is 1, 2, 8, or 9, but it already sees a 1, 2, so it's not 1, 2. This digit is 1, 2, 8, or 9, or 3, of course, but it already sees a 3 and already sees a 2. 3, 8, and 9 in row 6 can't go in the vault, so they have to go over here. And it can't go there, and it can't touch this vault. So that's a 3. That's an 8, 9 pair in here, which means these are 6 and 7. Row 9. Oh, where does this digit go in green? It goes right there. Make it this black over here. So where does this digit? Oh, no. No, where does this digit? No. I was going to say, where does this digit go in here and say it's right there, but it's in one of those two. Hidden triple in column 5. Yep, right here is 4, 7, and 5. Be careful not to fill in that cell. So let's look at 2 in this. Where does 2 in this region go? Not there. So it has to go right here, which fixes whether 1 or 2 is in the vault. It's 2. That's beautiful. So that's 1, that's 2. We know that that doesn't do anything. Blue can't take 1. Struggling to see that, but can we do anything else with this? Oh, these two cells need to be 1, 2, 3, 8, 9. That can't be 9 or 3 or 1 or 2, so that's an 8. That cell can't be 1 or 2. 1 in row 7 is right, because there's no 1 in here, and this region already has its 1 and 2. So that's a 1, which means that's not in blue. Oh, so that's blue, not green. And that needs to take that, which means it's not taking that. How many cells does this need? 1, 2, 3. It needs one more cell, which we know where it is. It's right there. Oh, whoopsie. Okay, blue done. So this either takes that or that. Can this reach that? Is that too many cells? That's 7 plus 3 is too many cells, yeah. So that means this has to take that. So where does the 1 go in row 1? Not in any of those cells. So in one of these cells? Thought that would be fixed for some reason. That's a 2 now, so that's a 1, so that's not a 1. That's now a 2, and that's now a 1. So that's not a 1. So the black 1 is in one of these two cells. Because if this was a 1 and it was orange, then this would be the black 1, and that wouldn't work because it would cut it off. So that is orange, which means that's orange. 1 in column 9. Oh, 1 in yellow is a better idea. That's a 1, which means that's a 1. Done. Woohoo. Done 1. And that 8 reveals that that's a 9. So where does 9 go in this region? It has to go there, which means that's an 8. That's no longer a 9. That's now an 8, a 9, sorry. Okay. Two in blue has to go in one of these two cells, but it can't go there, so it has to go there. Two in this column, maybe, is in one of these two cells. Two in this column is either here or there. And two in this column is in one of these two cells. So therefore, that's not a 2 and that is a 2. I think there was probably an easier way to do that. There's a 4 in here. So these are 4, 6, 7. These are 5, 6, 7. So 5, 6, 7 triple, which means these are 4 and 3. What about these cells? Those are 6, 7, 8, and 9. That 9 gives us an 8 here. Don't know how I didn't see that. So that's not an 8. Isabella catching that right after me. These are 4, 5, 6, and 7. Don't see any eliminations, actually. Yeah, I guess the big cage is... I guess this is 4, 6, or 7. Okay. What about 8 in this thing? It's in one of these two cells. Oh, that's not a 6. So there is a 6 in one of these two cells. Okay. 3 in blue. Oh, places 3 here. Because that's not a 3 and that's not a 3 now. So that is a 3. So let's hunt 3s now. There's a 3 in one of these two cells. There's a 3 in one of these 3 cells. That was a very short-lived hunt of 3. 5 cannot touch the 5. Yes, 5 cannot touch the 5 cell vault. You're right. Good thinking. So this is also from 4, 5, 6, or 7, which means these have to be a pair, right? Those are 3, 9. 5 in row. This looks up at the 7 there. Good spot to JC, Godart, and Isabella as well. So these 3 cells are from 8, 6, and 4. That's not a 6. Those are not 7s, of course. You guys always trying to make me do basic Sudoku. This is not 6. Okay, maybe we should look at our regions. So we don't need a 3 for orange. So one of these 3s is the green 3, because the black doesn't need a 3 either. So green has to come at least to there, which is 4 cells. So that's 7 cells of green. So where does green... Okay, what about 8 needs to be in one of these 3 cells. Row 6, column 9, and row 7, column 9. Right, so there's a 7 in one of these 2 cells, so there can't be 7s in either of these 2 cells, because that would mean that there wasn't a 7 here and there wasn't a 7 here, which means that in these 2 cells there is a 7 now, which places a 6 here and a 7 here. That's wild, because then that places a 7 here, which places a 7 here and a 5 and a 6 and a 5. That was a really good spot, Chameleon. Good job. That's not a 6 anymore. Row 4, column 1 cannot be orange and cannot be black. This is 6 cells. It can only take 3. This is right. That obviously can't be orange or black. Yeah, because green needs to get all the way over here. So that then these 2 are now green as well. Ah, yes. So now this can't be a 4 because it touches the vault. So that's an 8, which means these are not 8s. This is a 4-5 pair in the row, which gives us that digit is a 7, which means that's not a 7. Nothing in this column is a 7 because there's a 7 in it. Let's see here. Should be pretty close now. 2 in column 4 is resolved. Oh, because the green 2, yes, of course. So that's a 2, which means that's a 2, which means that the only thing that can take this 2 is orange. So that has to be a black 2. How did everyone spot this at the same time? Isabella. Okay, what about this cell? That can't be a 6. So where does 6 go in this row? In 3 places. Row 1, column 2. Ah, yes, this digit has to go down here, of course. That's a 6-9, which gives us a 6-8-9 triple, which gives us a 4-7 here. Which should do something. Surely it must do something. Well, there's a 4... There's a 4 X-wing here, which eliminates 4s from these, which gives us a 5 and a 6. What the heck? So that's a 4, that's a 6, that's a 4. That was crazy. That's now a 4 and a 5, and a 4 and a 7. It's okay. Hello, Codec. It gets a bit murky at the end of an irregular Sudoku that's not finished yet, you know. Solve path gets away from you. Let's just fill in all the digits so that we can answer the question of how does this finish. What are this 8 and 6? These are 8, 9, and 7. these are 3, 6, 9, and 5. Black already has a 6, of course. Thank you, ranks. So that's an 8. That's a 6. That's a 4. That's a 6. That's not a 6. That's not a 4. So that's a 3, which means that's not a 3. That's a 4 now. Just going to place a 4 here. No 4s there. Those are not 8s. That's not a 5 because there's already a 5 in orange right there. So that's not a 7. That's a 7. That's an 8. That's a 9. That's a 5. Those are not 5s. That's not an 8. That's not a 7. That is a 5, which means that's a 5. And that's a 7. And that's a 7, which means that's not a 7. And green already has a 9. So that's an 8. So that's a 9, so that's an 8, that's a 9, that's a 6, 6 up here, 8 down here, no more 6s, and we have a deadly pattern. Obviously, the puzzle is not unique. I'm joking, of course. This is black. Let's see here. It needs a 5, so we're going to get that there, and that finishes black. This needs a 9, which it will have to get from here. That has to be a 9. This has to be a 3, which has to be green, which we've established before. So that 4 is green, which means that's orange. And I completely forgot about the bet cell existing until just now. The bet cell is a 4. If you bet 4, good job. Oh, we didn't finish at all. We forgot to fill in this 9 and this 3. Now we're done. Definitely need a little bit of a break after that one. Yeah, that was a fantastic puzzle. It's definitely worth the wait. And I have waited quite a bit. Mistake at the end, start over. Yeah, it definitely needs quite a bit of concentration. Oh, yeah, I made a mistake. This is not orange, it's grains 5. Yeah, you made this. When did you make this one? Quite a while ago, huh? Oh, geez, December? Wow, I put this off for a while. All right, well, I'm gonna go on a break, and then I think we'll do one more puzzle, and then we'll call it. So, Kagisho made you like CC. That's good. Okay, I'll go on a break, and then we'll solve one more puzzle, and then we will be done. I have returned, despite you not being able to see me. Okay, let's see here. What do we have for puzzle number 3? Puzzle number 3. Get rid of the... Oh, here we go. Seems to be another old puzzle, Caravan VK3. Yes, you get to vote. Hello, La Ropskia. We have a first hidden skyscraper killer Sudoku with cages that go off the grid by now. We have a plane, or not a plane, an anti-king arrow. You should be able to vote. Actually, I'm not sure how you vote on YouTube. There should be some way to vote. Also, vote in the election. You should have a poll in chat. I'm not sure if it works on all, at your local polling center, yes. I'm not sure if it works on all platforms. Ah, it showed up, okay. And I think the Caravan puzzle is an anti-knight killer XV Renban clone. Which seems to be the leading choice right now at 13 votes. No worries now. One of your puzzles is up for voting. Welcome. All right, well, the first hidden skyscraper killer Sudoku, yes, the FHSKS. Okay, we'll call it there because there's 15 votes and 15 viewers, and it looks like number 3 has won again. I've run out of number 3 puzzles. Seems as though OBS again has decided that it would like to just randomly turn things on and off, which is fun. Oh, has this not even rated yet? No, it's only been solved 6 times. So this might be a bit harder than what I thought it was. Okay, so I also grabbed some tea in a mug that is as atrociously red as my shirt. Yes, it needs a rating. It only has 6 solves apparently. Caravan is a great author, so he should have more solves than that. But anyways, should only come in at about 3 or 4 stars. Okay, so we have anti-knight, which means that if I were to put, say, a 1 here, then these cells can't be 1s because it's anti-knight, so that's a knight's move away from that cell, and they can't be 1s. That would be a problem, and Sven even knows it's a problem, so that's good. We won't have any problems there. Killer cages add up to the total, so for example, we could put 1 and 3 and 6 in this cage to add up to 10. That would work. They can't repeat digits either, but it seems that they are not able to repeat digits anyway. Clones, so these 2 cells have to match these 2 cells, so if I put a 1 there, that's going to be a 1. 2 there, that has to be a 2. No relation to the values in them, just the exact same orientation of the exact same digits, and the same for these two green cells. The XV rules mean that the cells separated by a V have to sum to 5, and the cells separated by an X have to sum to 10, a lot like these killer cages, but these can overlap a lot easier. The Renban lines here and here have to contain non-repeating digits that form a consecutive sequence. So, for example, 1, 2, 3, 4, 5 would work, for example. They don't have to be in any particular order. They can just be anywhere, and they just have to be consecutive all together. So let's put in the bet cell. Kuraban suggests row 9, column 3. We'll use red for my red shirt and red mug. And we will begin our puzzle here. So I think we should start by noting that these V's can only be from 1, 2, 3, 4, which will mean that these X's have to be from 6, 7, 8, 9, and we can immediately put a 5 right there. And I bet that row 1, column 5 is a 5. Yes, place your bets on what digit goes in this cell. If you get it right, then you get the pride of getting it right. Welcome back, Chip. Oh, 5. I don't know. I meant to press 5. Yes, 5. Yes. So, strange looking 5. Also, this 5-cell Renban needs to have a 5 on it because if you have any 5 digits lined up, you'll need a 5 on there. So there's definitely going to be a 5 in one of these two cells. And what else can we say? Well, we know that these cells can only be from 1, 2, 3, 4, 5, 6, because if there was the best you could do here is a 3, 4 with a 5, 6. So they obviously have to be from those. So that means, oh yes, of course, this has to be high as well. Excuse me. Oh, 3 plus 4 is not 5. That's a good point. So the best you can do is 1, 4. Oh no, the best you can do is 2, 3 with a 4, 5. That's the highest you can get. So the highest you can get in these 4 cells would be a 5. And one of them is going to have to be 1, 2, 3, 4. So in fact, one of these is a 1, 4, right? That will have to have a 2, 3 down here. So the other one will have to have a 1, 4, and 5. So it will always have a 4 in it. A little bit interesting. Yes, 3 plus 4 does not equal 5, and the digit 4 is not the digit 5. These are facts you learn if you listen to chat. I think I need another sip of tea to revitalize myself. Yeah, they can't both. Can they not both be 1, 2, 3, 4? That's the point. Carl says they can't both be 1, 2, 3, 4, and he makes a beautiful point. If there was no 5s in here, you would have 1, 2, 3, 4 here, 1, 2, 3, 4 here, and then you would need to place 1, 2, 3, and 4 in row 3. Well, they can't go in those cells, they can't go in those cells, so 1, 2, 3, and 4 would go in these 3 cells. And that does not work because those are only 3 cells and you need 4 digits in them. So therefore, there must be a 5 in here, and there is no 1 in there, which means that these cells are 2, 3, and 4. And there's a 1 in here with a 6, 7, 8, 9. Which means these two cells are also 6, 7, 8, 9. Oh, that's the wrong cell. Which means we almost have a triple here, or a quadruple, I mean. No 5 in row 2, 3, and 7. Oh, anti-knight, of course. This 5 sees those two. Okay, I'm gonna turn on I normally don't have show scene or sorry. I normally don't have check pencil marks on, but for anti-knight, I'm gonna turn it on because yeah. I often forget that anti-knight exists for some reason. Even though I literally just talked about it 20 seconds ago. So yeah, anti-knight definitely rules out 5 from those cells. Does anti-knight do anything else? Probably. Yeah, anti-knight may come up once or twice. Well, if that's a 5, then that's a 5, and then that won't be a 5. Anti-knight. The 10 cage looks really suspicious. Yeah, this cell can't be 2, 3, 4, or 5. Could be 1, though. So I don't think we really learned much about it. No matter where the 5 is on the Renban, row 2, column 8 is not a 5. So if this was a 5, struggling to see why that rules out 5 from this cell. Where does 5 go in this box? Well, it doesn't go here. Ah, so then it must go here, which rules out the 5 anyway. Huh. So no matter where the 5 goes here, that's not a 5. So that has to be a 5. Is that the intended step? I'm just curious, Guraban. I mean, we're gonna use it, but okay. Oh, what the heck am I doing? That's definitely wrong. This is the other way around. This is 1, 4 with a 2, 3, 4 there. So that's not a 4 by anti-knight. Oh yes, okay, so the other way to do it would be if this was a 5, then you can't put a 5 in box. 9 at all because 5 can't go in here and 5 can't go in there because of this 5. Okay, that seems interesting. Or easier in a way. Okay, so that means that these cells yes, X's in row, yes, these clear pencil marks quite a bit. Not 6 and 7, 7 and 8. Okay, so you also know this digit goes there. That's worth anything. No, not worth anything to me. Okay, so what else do we know? Don't think we know very much. Can't be 4s in either of these two cells, because if there was a 4 here, it would rule out both of these 4s. Also, that one sees a 4. Ambrose is saying that this would break the 10 cage, because the 10 cage would need to be 2, 3, 5 in this case, because the only 10 cage that works without a 1 is 2, 3, 5. But then using the Renban, using the Renban would need 2, 3 to be here and 5, but that doesn't work. Interesting. Okay. So that is not a 1. So this needs to be from 6, 7, 8, 9. Because it can't be 2, 3, or 4, because those all see it by either Sudoku or Knight's move. And it can't be 5 because 5 is in the row. So that means I mean, it's the same thing if 1 is here, right? That's 2, 3, 5. You can't put 2, 3, 5 on here. Oh no, 1 can't go on this line at all now. Because if it did, then it would need to go with a 6 or higher, and that doesn't work. Yes, 1 can't reach 6, as Ambrose says. So we need to find a spot for 1. It seems like it could go a lot of places. I guess in this column, 1 can't go on any of those cells, so 1 has to go in one of these 3 cells. Row 4, column 5. Oh yeah, that can't be 1 either. So 1 is actually in these 3 cells. I don't know how useful that is, but it's true. This can't be 1 or 5, which means it needs to be 2, 3, 4, 6, or 7. Because 8 and 9 don't work in a 10 cage. Yay! Andrew Sakis' power is back on. Hmm. I guess in the same vein, 5 can't go in any of these cells. Because if I put a 5 there, that can't be a 5, and those can't be 5s, and those can't be 5s. So actually, 5 can't go in any of these cells. 5 can't go in those two cells. It's not quite there. I guess this needs to be high. Why does row 4... because of the clone. This is in the same box as this. No worries. So at least one of these is from 1, 2, 3, 4. This is a whack puzzle. Getting very few ideas here. Seems very tight to me. If this was a 5, then this would need a 1 in it, which would exclude 1 from being in that cell and place 1 down here. Actually, wait, this can't be a 5. If this is a 5, that sees this cell. No, 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 no. I was getting mixed up with this cell. Yeah. Well, that no, of course that can't be a 5. Oh, okay. Well, that can't be a 5. Because if that's a 5, that's a 5. And then there's no place for 5 in box 9. So we know these can't be 5s. Just not enough. I'll mark it anyway, just so we remember that. That's not what I meant to do. Okay, so let's try to think about wait a second. What about 1 in this box? Can 1 go there? Because if 1 was there, then there would be a 1 in here and there couldn't be a 1 in there. So this would be 2, 3, 5 again. Is that an issue? No, because now 1's not on the Renban. Starting to get a little dizzy looking at this. Oh, it's very warm in my apartment. Maybe a hot cup of tea was not the best strategy for a warm day. Row 5, column 7 sees the entire Renban via clone. Huh. So this has to be 1, 1, 2, 3, 4. Any of those digits. But definitely not on the Renban. And in here, in row 4, the 5 is either here or here. But that's not helpful. Oh yeah, it can't be here because then it wouldn't be able to go here or here. And it can't be in any of those cells because of this 5. So it's either in here or here. That's a good point. Sorry. We'll mark those with pink. And we'll remark these with red. And remark these with green. Okay, so is there something this does? Like maybe in this box? Well, that can't be a... No, it can be a 5. Let's just think about that. No, that can't be a 5 because of these 5s. So these can't be 5s. That one, well, that can be a 5. But only if these are 5s. Which would place a 5 here. Which seems fine. Would mean that there's a 5 in one of these two cells. Does this digit see the whole Renban? No, it doesn't see that cell. It nearly sees the whole Renban. This digit does see the whole Renban as well. because it sees that cell via night move. So how does that one not? Oh, because this is in the same box. Row 5, column 6. Yeah, those both see the whole rain band. So we can label those with our special digits and give them a yellow color. We're making some progress. I'm not sure if it's useful, but hmm. Oh, this is yellow. Because this digit does not appear on the ren band. Because it doesn't appear in those cells and it doesn't appear there, and it's not 6, 7, or say 6, 7, 8, or 9. Oh, no. I was going to say this one is 2, but it can be that cell. So if we could just get this to be a 4, then we would be in business. Sort of. I mean, barely. Two, 3 minimum in row 3, 4, column 5. Sees a lot of the LRN band. Okay, so I mean, if this was a 2, 3, right? Then this could be 3, 5 at best, and then like you could do 4, 6, 7, or whatever, 7, 8. Wait, no, not 4, 6, 7, 8, just 4, 6, 7. But if this was not 2, 3, if this was something higher, so if this wasn't 2, 3, then it would be a 4, 6, 7. Now, if it's a 6, obviously it goes there. Sorry. Sorry. Let's go with Andrew Sakis' point because it sounds smarter than what I'm doing right now. Row 1, row 2, column 8 must have exactly 1 repeat on the V in box 9. Right, okay, so the other digit must go in column 7 of box 9. Okay, so it's on the ren band. Yes, that's true. So one of these 2 digits cannot go here because it's either 2, 3 or it's 1, 4. It can't be both. Contrary to previous attempts, 3, 4 does not go on a ren band or does not go on a V. So what we have to do is we have to put one of these 2 digits down here. Now we know we can't put 1 down there. So we have to put either the 4, 2, or 3 down here. which means that it'll end up here, which is on the ren band. So there's no 9 on the ren band, because there's at least a 4 on the ren band. And that also means that in these 3 cells, we have to have 1 and 9. For sure. Row 2, column 8. Row. Oh, this digit equals that digit, which we said wasn't important, but it is. So this digit sees that digit by knight's move. Like if I put a 2 there, that has to be a 2. So those are the same digit. Let's give them an orange color. These are the same digit. But this digit sees that cell by knight's move. So this digit can't go there, but it also can't go in here. Which means that the digit in here that goes in here is not orange. So orange goes over here, which must mean that this is a 2, 3, which means that this is a 7, 8. But more importantly, this goes over here, but cannot be 1. We've already established that 1 is not on the ren band, so this must be a 4. This must be a 1. There's a 4 on the ren band. There's a 4 in one of these 3 cells. That's a 9. That's a 6. There's no 9s in here. That's not a 1. That's not a 9. That's not a 1. Those are not 6s. Whew. There we go. That's really cool, Kerban. Well worth the effort. So there's definitely a 1 over here, which means there's a 1 over here. What else do we know here? Surely this 9 gives us something, because that means none of these cells can be 9. So there's a 9 over here. Yellows are not 7s. Yes, the yellows are not 7s because we know there has to be... We know this digit is not on the ren band and it's a 2 or 3, so there has to be a 7 there. Yellow is not 4 because 4 is on the ren band. This yellow thing is paying off. No, you're right. You're right, Isabella. 7 does not go on there because this digit is not on there. This 2 or 3 is not on here, so therefore there must be a 7. So you were right anyway. The tea has cooled off now, so I am no longer being stricken by my own tea. Wait, these 9s and this 9 means there's a 9 down here. Oh, wait. Where did 9 and 1 go in this column? This 1 removed a 1 from here, so this is a freaking 1-9 pair. That's cool. Now what do we know? We know the bet cell's not 1. Sorry for everyone who lost their 1. We know this isn't 9, 2 anymore. So it's either 3, 8, 4, 7, 5, 6. That's a decent pencil mark. If it was 4, 7... The 4 would have to be here. Oh no. Row, yeah, this is not a 5. because there's a 5 in one of those two cells. There's also a 6 in here. Does that mean anything? 5, 6. That would mean that this is a 6. It's fine, I guess. What about this thing? So this is either 5, 2, 3, or 1, 2, 7, or 3, 6, or 4, 5. Orange in box 6. That seems very profitable. Orange can't go there, so orange must go here. So that is a 2, 3. That's not orange, that's not orange. The anti-knight doesn't help us at all. Orange is up here. That's sad. What about... Yeah, orange is 2 cells in box 9, but we use the anti-knight from this one. And that can't be orange because of that. The other 2, 3 in box 6 can't go there, can't go here, can't go there. So it's in one of these 2 cells. Which means this can't be 2, 3. If that was 2, 3, think about it, if that was 2, 3, those can't be 2, 3s then. Nice one. So that can't be 2, 3. Sorry, one sec. The other 2, 3 sees row 5, column 6. Row 5. Two, 3 in box 9 sees the 2, 3. Yeah, I mean, we don't know which one it is though, Isabella. We don't need these to be yellow anymore. Actually, yellow we can just get rid of. Unless this is an 8 and then we know there's no 8 on the thing. We don't know which of these is yeah, one of these two is orange. We're not sure which one. But those the other 2, 3 is in one of these two, which means the other 2, 3 can't be in either of those. And the other 2, 3 can't be in there. And the other 2, 3 can't be here. It's not clear yet. If we could get this as an 8, then we would know that there is a 2, 3 on here. Okay, let's think about, if there is a 2, 3 on here, where does the 2, 3 go? It doesn't go there, and it doesn't go in these two. So it would have to go here. Row 4, column 9. can't be a 1 because of the clone, right? Okay, so that can't be a 1. So if there was a 2, 3, it would have to be here. The other 2, 3 in column 5? Oh. This is a 2, 3. Yes, you're right. Because those can't be 2, 3s. That's brilliant. So this is 4. Yes. This is good. This is 2, 3. So now this is the other 2, 3. Which is sorely missing from many places that this sees. So I'm not sure how useful that is, but it exists for sure. Wait, now this is interesting, isn't it? Because now this can't be a 2. This could be orange and this be a 5. Or this could be a 1 and a 6, 7 thingy with a 2, 3. But we can't do many other things now. 4 in this box is in these 3 cells. Because that can't be a 4 because that would rule out both of these. Oh, no, wait. 4 doesn't need to be in here. Wait. Yes, it does. Yes, it does. Because there's no other place for 4 in column 5. That can't be 4 because there's a 4 in one of these two in this column. So that means this is not a 4 because that would rule out both of these. So that can't be a 7. So there's a 4 in one of these cells. There's no 4 there, there's no 4 there, there's no 4 there. So there's a 4 in one of these two cells, but it can't be here because we just ruled it out of there. So that's a 4, that's a 1. Oh my word. I'm right ahead of you, Philippe. Okay, we're almost there. There's a 4 in one of these two cells now. Ooh, it's placed. There's a 4 down here. Therefore, row 4, column 9 equals row 3, column 8. Yes, it does. You're right. These are all equal. Why did you retract that? Is that not correct? Oh, this is not a 6 now. Okay, it is correct. Okay, good. Not particularly helpful, but it's okay. Is it really from 5, 7, 8? Why can't it be a 9? Oh, because of the Renban. Right, okay. Good spot, Ambrose. So now this can't be 9 either, because the 9 in column 9 is in these two cells. So that's also from 5, 7, 8. I guess we can label these the same as these. I guess this is from those digits. I don't know. Um, so in this box, the 9 is in one of these two cells. Is that right? Yeah, because of the column. So then the 9 is in one of these three cells. Hmm. If this was a 2-3, then that couldn't be a 2-3. No, wait, it could be a 2-3, couldn't it? Because no, this sees orange. Orange is definitely not on this Renman then. So if this was a 2-3, it would be the other 2-3. So therefore that would be the other 2-3, and then that would be the other 2-3, and that would be orange. Is there an issue with that? Right, you have to put 2 on the Renman, or 3 on the 3 obviously on the Renman. So that would mean orange is 2. Is there a problem with this 11 cage if that's true? This seems like a very, this seems like it might go far, but let me just think about this for a second, because then you would have to put a 7 here. You couldn't put a 3 on here. So you couldn't put an 8. And you can't put an 8 on the Renban then. So that would be a 4-6. No, I don't think so. I was thinking that 7 would be ruled out of here, but it wouldn't be. Row 5, column 6 is interesting. Yes, it definitely is interesting. 8 puts 3 on the Renban. Yeah, okay, so let's think about those two options and what they have in common. Oh my word. No, 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 no. I was going to say they both put 5 here, but actually one of them removes 5 from there and the other one places 5 there. Because if this is an 8, this is a 3, and this is a 5, which would place 5 there, of course. Whereas if this is a 1, then this is a 5, so then this is a 5. Wait, so then this is either 3 or 5. That's weird. Because this is by value, and if I put a 1 there, then this is a 5. And if I put an 8 there, then this is a 3. This is either 3 or 5, weirdly. Okay. What does this mean? This can't be a 5. Actually, 5 is only in... Wait, 5 is in one of these two cells, because 5 is in one of these two cells in this box. Because we can't put a 5 in any of these cells, because then we'd have no place to put 5 in this box. So that's not a 5. Weirdly. There is a 5 in one of these two cells. So if there's a 5 here, then there is a 5 here. Which also means there's a 5 here. of the 1-8 scenario. Oh my word. This puzzle is boggling my brain. Well, let's see. If that's an 8, we know this is a 3. So then that would be a 3, that would be a 2, that would be a 3, this would have to be 1, 1, 6, yeah. So we know that there's no 7 in here. Let's see. Because we know that either it's 1, 2, 3, or it's 3, 3, 2, 3, 6, and 1. I think row 7, column 6 is a 5, or row 7, column 5 is a 6. Why? So wait. Oh, because this would be a 3, 6, 1. So there wouldn't be a 6 in here. Okay, so either this is a 1, which means that this is 1, this is 5, 2, 3, which places a 5 here because there's no 5 there, which means this isn't 5, 6. Or this is an 8, which means that this is a 3 and this is a 2, which means this is a 3, this is 1, 3, 6, and there's no 6 in here. So that has to be a 6, which means there's no 6 in here, which means this is not 5, 6. So either way, this is not 5, 6. Can remove 6 from column. Yes, we can remove 6 from there because that can't be a 6. So there is definitely a 6 in one of these 3 cells. There has to be a better way to do this. 7, 8 pair in box 2? Oh my word, there is a 7, 8 pair in box 2, so that's not 7, 8, that's 1, 6, which means that's not a 6. Does that help us more? Please. Color the 7, 8s. Okay. I'm willing to do it. Blue and yellow. So there's going to be a blue on here. And a yellow in here. Blue in box 3. Oh, that's blue because this sees it by knight's move. Blue in box 1, well, that's definitely yellow. So that will be blue, which means it's not 9. which means this is 9. Oh, okay, okay. There is a yellow in one of these two cells. No yellow here, no yellow here. So there's a yellow in one of these two cells. So there's no yellow here. Yeah, remove 9 from the top red, which means 9 is there. 9 in this box is over here. 5, 7, 8, tripling column. Yes, so this has a yellow in it. So this has a yellow in it. Row 9, column 9. Yes, that has to be blue because there's a yellow in here. There's too many colors. Triple looks down. Oh, looks down. Duh. Okay, thank you. So there's not 7 or 8 in here, which means that's not a 6, which means that is not blue. That is blue. Which means blue in this box can't go there, is in one of these two cells. Blue in this box is there. Blue in row 4? That's not blue. That's not blue. That's blue. Oh my word. Holy crap. So that's blue. What does that do? Come on, do something. So blue down here is in that cell. And blue is in this cell. Please. Yellow is in one of these 3? Oh, wait. No, 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 no. That's not right. Does anyone see what that did? All that amazing work. What did it do? 2 in this box is in one of these two cells. Come on, you can't tell me that did nothing. Excuse me. Come on. There's no 5s here. It's 5 in one of these two. If this is a 5, then that's a 5. So there's also a 5 in one of these two. So there's a 5 in one of these two and one of these two, which means that there's a 5 in one of these 3. Weirdly. Hilariously, row 1, column 3. Oh my gosh, this is equal to this. What does that do? Okay, wait, if this is a 3, we know that blue is 7, which would make these 3s. Which would make this an 8, this a 2, this a 3. This is 6, this a 4. Don't see a problem with this. Oh, 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 oh. What we just did. What we just did. What we just did, saying if this is a 3, then this is a 3 and this is a 7, which would make this a 7, and this has no fill. Oh my word. Okay, so we can say that if there was an x here, if these added a 10, then this would have no fill. So these can't add to 10. So this has to be a 5. This is ridiculous puzzle. I've had fun. I've had fun. I could say that. So that's a 5, that's a 5, that's a 5. Okay. This is a 1. We know that. This is the scenario where this is a 1. So this is a 9 and oh, not a 9. A 6 and a 1. So that's a 6 apparently, and that's a 1. Which still doesn't place 1 in this box, but it does place the 6. Wait, no. Place the 6. Losing it. So this is a 1, 9. There's also a 9 down here because that can't be a 9. Weirdly. Also a 5 in one of these two. Is this really the option where it doesn't tell us as much? Oh, this sees that cell, so that's orange. Which means orange is in one of these two cells. Which means orange is not in these cells. Row 7, column 7 is yellow, yeah, for sure. So that will mean that this is yellow, right? Okay. So that's yellow. So that's not yellow, which means this is yellow. So that's a worse option, but yellow in box 9 is in one of these two cells. Yellow in box 4 is in one of these two cells. So row 5, column 4 is 9. I don't follow. It sees a 4, 6 pair. Okay, so it can either be 4, 6, or 9. And it definitely sees a 4. I can see that. I don't see where it sees a 6. Oh, it sees that one and that one by knight's move. Duh. So that's a 9. This is a 4, 6 pair. 4, But apparently it can't be a 6 because of this 6. So that's a 4, that's a 6, that's a 3, that's an 8, that's a 2, that's a 3, that's a 7. And it turned out they were 7s and 3s anyway. Oh my word. What a hilarious joke. Wait, we broke it? Oh, this cell has no value. Hard. Oh, we've broken it. Oh, yeah, we didn't know orange was 2. We didn't know orange was 2. Why did I put orange as 2? We didn't know that. Yeah, orange isn't 2. Orange is 3. I'm just stupid. Okay, orange is just 3. It's okay. Okay, there we go. I don't know why I thought orange was 2. I was just saying, oh, it's as we thought it wasn't, but I was actually wrong in that thought. So that's a 1, that's a 9. That's a 9, that's a 9. That's a 4. Sorry, that's a 1. That is a 6. This is a 6. One of these two is 8. Okay, let's think here. 5, 8, 2. So 2s are in those cells. So that's a 2, that's a 5. This is 9 and 3 and 5 and a 6 and an 8 and a 2, a 1, a 3, and finally, oh, finally an 8. So if you bet 8, you were correct. Now get rid of these disgusting colors. Yeah, amazing puzzle. Absolutely brutal at times, but very, very good puzzle. Yeah, vexing knights is a good name. There were really weird interactions with that. This whole 1-8 thing with the 5, and then we've had to figure out that this was either 5 and 6, and then there was this virtual 7-8 pair, and whew, it's crazy. So many little things you had to keep into account with. Yes, this was definitely a team effort. Thank you, chat, for there was a period of silence where we were all very much thinking, but then we eventually cracked it. All right, well, I think I'm gonna take a nap or something. So peace out. Hopefully you guys voted and you enjoyed the stream and all that. So have a good one. I'm sure there was an easier way to solve some of it, but yeah, thanks for coming out, guys. Have a good one. Remember to like the stream and subscribe if you're not subscribed and all that jazz. Patreon exists, all that stuff. Bye.